in bell work today, we are doing the same thing we did yesterday. Okay, we are trying to make this function a differentiable function. Okay, f of x is equal to, I've got a parabola and I've got a line. Parabolas are differentiable. Lines are differentiable. The only place that I might have a problem is at the piecewise point, at that spot where they break. In order to be differentiable, what has to be true? It has to be continuous. So the first thing I'm going to do on this problem is figure out when I'm continuous. To figure out if I'm continuous, I need to know the limit as x approaches 1 from the left. Needs to be equal to the limit as x approaches 1 from the right. From the left, it's this equation right here. From the right, it's this equation right there. That's how I'm determining whether it's continuous or not. I'm taking both functions and setting them equal to each other. How do I find the limit of functions? Plug in. I'm plugging 1 in for x. So if I plug in 1 for x here, it's just going to get me a. And if I plug in 1 over here, I get b minus 3. I can't solve that problem right now. Okay, I've got two different letters. I've got a and I got b, so I can't really do anything with that yet. Okay, I need some other equation to help me solve it because I've got two variables with one equation. So I need to be continuous. What else needs to be true? It needs to be differentiable. And what has to be true in order for you to be differentiable? Not a cusp. It can't be a cusp. It can't be a corner. So in other words, the slopes need to be equal. So if I want to know that I'm differentiable, my derivatives need to be equal. That's what we're doing over here. Okay, so same concept. We're finding the limit as x approaches 1 from the left. Basically, this function and that function need to be, their derivatives need to be equal. The limit as x approaches 1 from the right. I need to take the derivative of ax squared. Remember, a is a constant. What is the derivative of ax squared going to be? 2, because I'm multiplying by the 2. The a is a constant, so it's hanging out. And then I subtract 1 from my exponent, so it's just 2ax. That needs to be equal to the derivative of the other guy, bx minus 3. What's the derivative of bx minus 3 going to get me? Just b. Okay, if I told you what's the derivative of 3x minus, the derivative would just be 3. bx minus 3, it's a constant. It's just b. I'm taking these two things, I'm setting them equal to each other, and I'm solving. Oh, and I'm plugging in 1. All right, so if I plug in 1 here, I get 2a. I'm plugging in for x. There's nothing to plug in for the second one, so it's just 2a equals b. I now have two equations with two variables. Solve them. Okay, if you haven't gotten a chance to do that yet with your neighbor, solve those two equations right now. To solve this thing. If we were to solve this thing, Michael, what'd you do? You're good. A is equal to this, so I'm going to take b minus 3, and I can just substitute it in for a. So then I get 2 times b minus 3 is equal to b. And there's multiple ways of doing it, but that's one way. I get 2b minus 6 equals b. So I'm going to add 6 and subtract b. So b is equal to 6. If b is 6, then I'm just plugging back in. 6 minus 3 is equal to a. So a is 3. Those are my answers here. This could be a free response question. It could also be a multiple choice question. Okay, they've done a question like this in the past, and they're like, find a and b that it's differentiable, and find a plus b. Okay, that's kind of mean, but the answer would be 9. It'd just solve it and then add them. I don't know why they make you do that, but they could. Okay, let me show you what we just did, because I think it's important to have an understanding besides the fact that it's just super weird. All right, so we have this graph right here. It's going to be load super slow for me. But there's my graph. I've got a parabola and a line. The ax squared, that's my parabola. Okay, and the bx minus 3, that's my line. We just found my a and b. It needs to be differentiable. Okay, right now, definitely not differentiable because it's not continuous. Okay, my A is going to be 3, so it got a lot skinnier. My B is going to be 6. Is it continuous now? Definitely continuous. Does it look like the slopes are equal to each other? We don't have a corner point. If that B was anything else, then there'd be a corner point there. But if you look at it right there, it looks like just a continuous line. Okay, if I zoom out far enough, you'll see that the slopes definitely change. You can see how this one is definitely different than the other side. But at that micro level, at that small section right there, the slopes are equal to each other. And because of that, I'm differentiable. Questions with how we did that? All right, today we are doing a Big Ten review. This is very important. So if you're at home watching this, do the Big Ten review right now, okay?